I was told the audio was no good, so can everybody hear okay? Yeah. Excellent. Think about what this is. I'll tell you later on. I heard a couple of people mention it, but we'll get there in the end. So, all your codes belong to me. I'm Keith Howell. I was an electronics engineer for 10 years in the British military. I was a network engineer, security engineer for UUNet. There's a couple of people that in here I used to work with. And for various reasons, I was a professional locksmith and access control engineer. So that's why some of you have seen me in the Lockpick Village. And at the moment, I'm a security engineer for Assurance Data. And along with Mubix, one of the Nova hackers in this area. So if you're in this area, thoroughly recommend coming along to Nova Hackers. I'm going to go through a voyage into the secrets of alarm panels and a whole new world of security by obscurity. You can't find this information from the manufacturer. And I'm going to go through the whole process that a beginner will go through. Try and show you how to start looking at some of these hardware devices. We get a lot of people come in and say, here's my circuit. Well, I'm going to go right back and go through and show some of you, hopefully get you interested in doing some of the hardware investigations. So, I saw this brown box on the wall, and I thought, I wonder what I can do with it. Brad was showing us on the previous lecture about how you can open the door remotely. But, okay, you can open the door. I have an alarm system, says the chief security officer. Well, it turns out there's only 4 wires in this system. The ground, power, data in, and data out. Now, there's no secret to this. If you open the panel on an alarm system, it's right there on the inside cover of the front door. If anybody doubts it, they can come and look at both of these boxes. Right on the front door, it tells you exactly what the stuff is. But how are we going to start looking at it? What are we going to do? It's unknown. We have an unknown voltage. But you can make some guesses. It's got a 12-volt battery, it's got a 13-volt transformer, and it's in an industrial, commercial, or residential building. It's unlikely to have anything above 48 volts. That's documented, that's not OSHA, but there's a whole bunch of safety regulations about what voltages you can have. Unknown protocol. You can't find any information about the bus protocol between them. The manufacturer for these panels doesn't release that information. So, the tool to use is an oscilloscope. It has a high impedance. In electrical terms, that means it's not going to affect the circuit that you're measuring. And it's generally voltage isolated. So if there is a high voltage, you're typically in the 300 volt range. So you can stick it into a wall socket and you're not going to cause yourself some problems. Well, unless you touch the probe. And measurements are fairly simple. So I attached an oscilloscope. This is the signal that I got from the bus. So I'm looking at it, and if you can see up in the top corner, excuse me for only using one screen, up here, it says 2 volts per division. So if we measure from top to bottom, we've got 6.5 divisions and approximately 13 volts. Now, we take a few guesses. We've got 13 volts, serial cable. Is it RS485? Turns out, no. RS485 uses differential signaling. For every plus signal, there's a minus signal. And the wrong voltages, typically -7 to 12 volts. RS422 have the same problem, still differential signaling, and it's plus and minus 6 volts. So, what's left? RS232? We'll try that one. But there's no negative voltage, typically plus and minus 12 volts. There we go. And if you want some more information, images, protocol descriptions, I got all of that from Wikipedia. So what now? Well, of course, open source intelligence, search the internet. And after several weeks of trying, I come up with this. US patent 6868493, system and method for panel linking in a security system. Doesn't say much about the protocol, but it does have some very interesting diagrams about the packet structure that they're going to use for talking between panels. More reading, more searching. Come across this patent, or two of them. ECP bus proprietary RS-232-like protocol. So it is RS-232, but it's not measuring RS-232. So turns out if you actually read the spec, it's fairly flexible in what it will accept as a signal. It's definitely 12 volt tolerant on the input pins. So let's try the serial interface. Program I use, if you use Python on a Linux system, or you've got it on a Windows system or a Mac, the latest versions of Python come with Miniterm. It's a very simple, yes sir? Very simple, you stick your hand up, I'm going to ask you if you're asking a question. Miniterm, a very simple Python package for just attaching to serial devices. This is the usage. You can, very easy to find. It's not the full usage screen, that doesn't fit on a slide very well. And this is the physical wiring I'm going to use. So let's see if it works. Yeah. There we go, that one didn't work. There we go. Yeah. No, I'll flip it over in a second. I can't type and look backwards at the same time, so. Trouble is, I lost all my wires unpacking them all. Here we go. Yeah. And of course it's not working. Curse of Shmoocon. Let's try. Sorry about this, different wire. It gets easier. All right. The next one's work easier. Trying to hook into the serial into the USB bus, but you can see the signal that we're getting through there, and everything's coming over in plain text. So, what's the next step? So I want to hook up a logic analyzer. I want to see what this signal is, get some idea. Brad showed us an analyzer for looking at the Wiegand signals. But logic analyzer is only designed for 5 volts. And if you hook up 12 volt, you're going to let the blue smoke monster escape. And for anybody that's done that, Adafruit has a very nice achievement badge. And if you haven't let the blue smoke monster escape and you're doing hardware hacking, you will do. So the solution's an RS-232 level shifter. This is going to take the signal that we don't want to use and downshift it to 5 volts. First circuit I found was from SparkFun. Looking at the circuit diagram, it looked a little bit more complicated than I wanted to build. So then I found another one. This was by a gentleman called Sean Matthews, and it was posted on DIY security forums. And it's a very simple circuit, a couple of transistors and a couple of resistors. However, I couldn't find the transistors anywhere. Radio Shack doesn't sell components anymore, they're too interested in selling phones. So I ended up back at SparkFun, bought the kit of parts. A couple of hours later, I've got the circuit built, but I didn't want to use the wires. They give us some nice wires in the box, but I didn't want to use those. So I hooked a little connector up down in the bottom corner. And then we can hook up the logic analyzer. And that's made by Saley. Excellent piece of equipment. If you're going to do any hardware investigation, it's a very worthwhile purchase. Saley Logic. And that's where you can get it from. Okay, let's see if this one works. I have flashy lights this time. We'll get there. 1 second. This is the, let me hide a couple of those channels. Just capturing some signals and then I'll throw it across on the screen. Nope. Sorry, it's dark up here, I can't see the right colours. Okay. Can you hear me through this microphone? Okay. So, this is a live capture I just did. So if we zoom in. Yes? Go ahead. And we can see the serial signals. And if I didn't get it, add another recording. But the circuit that I've got is only designed for one channel at a time. So I'm trying to monitor both lines. There's a transmit signal and there's a receive. So Maxim 232 chip. If you haven't come across these, they're designed for 2 serial signals in and 2 out. It's a very simple design, and this is just the circuit I need to build. It's very common. The capacitors that you need are very, very simple, very easy to get, simple to solder, and you end up with a little circuit board like that. The answer to the question that I put at the start is that picture is a microscope capture of one of the solder joints. Bobbit got it. Just down there. I went right in real close. So anyway, we can capture both data lines. And I guess I'll skip ahead. I'm running a bit behind. We capture the signal, but we're missing some of the data. You cannot see, it says demo, disarmed, and it's supposed to have 4 asterisks at the start of the signal. That's what comes up on the displays, on the keypads. So instead of the first asterisk, it's got 170. And the protocol analyzer actually complains that it's out of spec. It complains that there's a stop bit missing, or that the parity is wrong. So back to the internet. And I came across a very interesting article in Circuit Seller magazine, and called Reverse Engineering the ECP Bus, where somebody had done some work, a gentleman called Miguel Sanchez. And I can't show you the pictures from this article because I purchased the article and I don't have permission to pass it on, but Circuit Seller magazine issue 201 if you want to get hold of that information. He details the problems with the serial interface, the protocol violations, and also the timing issues, trying to work with this interface through a serial port from a PC. And he ended up using a Rabbit microprocessor, but they're rather expensive. I think the basic model for that starts at about $300, $350. So while I was looking around thinking, well, maybe I'm going to have to build my own circuit, I came across, back reading DIY security forums, someone's already solved the problem for me. This is wonderful. NewTek and the gentleman, Sean Matthews, who I mentioned earlier on when he did the circuit diagram, he'd already built a microprocessor. It's a PIC controller, interfaces fully with both buses. He's produced a virtual keypad software, and it uses a standard FTDI chip for interfacing to the bus, into the USB bus. So I can use it from Linux. No more messing around with a converter. Don't need the level shifter. And that's where you can get the device from. The links are at the end on the final slide, so you can take a picture of that or note it down later. This is the device. That's the virtual keypad that he's produced. And what can it do? Full interface. It correctly interfaces with both the transmit and the receive interfaces. Standard ASCII. Keystrokes. Any keystroke you type in, if it's valid, it'll convert it and send it down the bus at the right time. And then a simple Python program does the rest. So It's a time-lapse movie. I decline to answer that question. Not on film. I haven't had the resources to test across all manufacturers. This is funded out of my pocket. But you can see the percentage going down. I'll get to that question in a second. I was asking if this is transmitted back to the base end, so. Okay. One second. Okay, that time lapse was 30 minutes in real time, and it only did 400 numbers in 30 minutes. So to do all 9,999 numbers, it takes just over 13 hours. And Johnny Long asked me a question yesterday, so I ran back upstairs to the hotel room and I activated the alarm panel, set it on armed status. This still worked. So even if the panel is armed, this particular model of panel, this particular manufacturer, it throws a fault and it says zone disabled. But the technique I'm using to recover all the pins does not appear to set off any alarms, and it doesn't lock the panel out or lock the keypad out. Yeah, came up a little bit. I edited the slides last night and I guess I had too tired. Anyway, different panels have different features. I was asked if this was a particular manufacturer, and I can't answer that question because I've only tried a particular manufacturer and I only have access to 2 particular models, and the technique for recovering the pin numbers differs between the 2. If you're brute forcing through the pins, you can come across what they call a duress code. A duress code is not a good thing. The police, fire, EMS are probably going to turn up with blue lights flashing and wonder what's going on. And it can be logged. That's a stage I need to get into. Trying to interface with the system telephoning out back to a central station. There's a module for the Asterisk Open PBX software that will interface with it, but I've got more things to do on this end of things before I get to figuring out if I can break the back end. But there's got to be a better way than brute forcing. Yep. How about sniffing the wire? We've got both signals. We've got the transmit and the receive. But I can't see the keystrokes with the default firmware. But Sean Matthews and I had a rather long conversation, and he determined that I wasn't trying to burglarize establishments and decided that he would let me have a copy of the firmware with debug code in it. And so I wrote a little module for his virtual keypad, which, let's see if that one works. Sorry, I confused it. Sorry about that. Happens when you're trying to plug too many devices in at the same time. As Skydog noticed, I've got more equipment on this table than anybody else he's seen so far. Yeah, turns out I'd really confused it. Here we go. Okay, so does anybody else remember one of the pin numbers that were up on the screen earlier on? Oh, you had to remember the 1337, didn't you? Yeah. Oh, look at that. So it's reading the keystrokes as you type them in. So the question then was, how do the other devices communicate? Was this also in plain text? So I've got the keystrokes, but what about everything else that's attached to the system? Turns out they don't quite transmit in plain text. It's a binary format that's packed into the bytes and then transmitted. But this is the data from the keystroke. This is actually what I interpret when it's coming back. You can see 1, 2, 3, 4. That's what was sent on the bus. It's a header, followed by the number of bytes, followed by the data byte, and then the checksum. So as I'm working on all this, I'm suddenly seeing strange data appear. And it didn't quite break, but my little program crashes sometimes. It's picking up any RF device in the vicinity. And most sensors that are RF sensors send out a supervisor signal. So you get a regular check-in to the panel. Otherwise the panel alarms. Here's one of the unknown data. And Sean Matthews interprets this data and actually shows it on his software. This is more of it. Only the 27768 was my data. That's my sensor, which is on my panel. It turns out that some of it is actually my transmitter sending data. So that's the 27768, which is my sensor tripping, and the other RFX messages up there are what's coming from the transmitter and actually being picked up by another system. Last night, or yesterday, I set my system running up in the 10th floor, put the receiver by the window, and these are all of the RF sensors that I picked up in the local area. You've got to remember, these things are less than a pack of cards. You can see the little white sensor just on the top of the box on the left-hand side there. And this is basically one of the sensors. There's the loop 1 is triggered, which is the 8-0, then 0-0 when it's reset. And then you can see further down, I went offline, I took the computer away and had to do some other work, so it wasn't recording. But then later on, you can see loop 1 supervisor check, which is the 0-4. And go down and reset. This is probably a motion sensor. I had to edit this, otherwise it wouldn't fit on one slide and be legible. This sensor was going off from 8 o'clock in the morning when I turned it off until 10 o'clock at night when I shut it all down. And I was getting messages, over 200 in one day. So what good is all of this? Offense, intelligence gathering. If you can monitor the sensors inside a building remotely, we're not connecting to anything, we're just listening to their RF transmitters if they've got them. Covert entry. If we can pick up the pin numbers through the RF signals, then we can come in later. We can use Brad's technique, opening the door, but now we can get to the alarm panel and disable the alarm system using one of their pin numbers. But on the white hat side, we can use it for auditing. Check for bad pin numbers. One of the second-hand panels I picked up, nobody knew what the pin numbers were. The fourth one I tried was 1111. And it worked. Also logging the RF sensors, if this is your system, you're logging your sensors to your internal servers as part of your monitoring. And activity tracking without an alarm. These sensors trigger all the time. Just because it's not triggering an alarm monitoring company would only know when you trigger an alarm. They don't have this sort of information. And of course, any suggestions for what we can do with this work. It's a work in progress. I'm still working on this. It's been since October. So it's been about 12 weeks I've been working on this and got it this far. Need to decode the RF messages in more detail, analyze more of the messages to see if there's any, determining what the sensors are, if there's any serial number matching between sensors. And there's more RF devices. eBay is my best customer. I'm one of eBay's customers, best customers at the moment, buying some of this second-hand alarm panel stuff. And what can we actually learn without physical access to somebody else's system? At the moment, to get the full effect, you actually have to tie into the physical wires. But by fire code regulations, alarm panels have to have nice, bright red wires running in the ceiling. So if you can lift up a ceiling panel somewhere in a building and you find a bright red wire and there's 4 cores in it and they're black, green, yellow and red, it's probably the alarm panel. And it's all one bus. For the further investigations, there are a couple of assumptions I've got to make. That the transmitter sending out data packets cannot confirm that yet. And that the wireless keypads actually transmit the keystrokes. And I have one wireless keypad, but it's not compatible with this system. So, a thank you to the people here. Sean Matthews was a great help. He gave me some information on some of the protocol once I started investigating a bit further. Adafruit and SparkFun, if you're doing any hardware hacking, they're great supporters of hardware hacking. Go and visit their websites. They've got a whole bunch of toys to start playing with. And Saley Electronics for their logic analyzer. Definitely get hold of one if you want to do this sort of work. Miguel Sanchez, I use some of the information from his Circuit Cellar article to help me get further on analyzing this information. And Matt Morrison, my boss, who wondered what I was doing, editing slides at work. And when I told him, made me wear a company shirt and said, if you're going to use my time, at least advertise us. So, any questions? Yes, sir. Yes. He asked if the RF sensors are just if the signal is just the sensors or the bus. The signals I currently pick up appear to be just the sensors. However, I am getting data. I have two panels. One has got a transmitter-receiver combo, the other just has a receiver. If I trigger the other panel with a sensor, I actually receive additional binary data, which I haven't yet got to. That's part of the work I need to be doing. So there are bidirectional wireless keypads. I have one in the mail. And I could then answer that question, but ran out of time before Shmoocon. I couldn't get the hardware in time to finish that part of the investigation. Yes, sir.
What frequencies are being used to transmit?
I knew somebody was going to ask it. He asked what frequency the signal's running on. I think, if I remember, it's 315 megahertz. But I am not using a RF receiver analyzer. I'm actually using the manufacturer's RF receiver. Anyone else? Thank you very much. Oh, yes, Bobek.
To the best of your knowledge, have you noticed any encryption or any kind of weird obfuscation? Is there anything that, what makes these transmissions not interfere with other systems?
Is asking if there's any encryption or they're obscuring the data in any way. There is no encryption other than packing the bits into a binary, packing the binary bits into a byte that then transmits it. I've found no encryption so far in anything. And if you have a sufficiently powerful transmitter, I'm pretty sure you could just jam the signals.
How do systems that are near each other tell each other apart?
When you want to use a sensor, you have to register that sensor with your alarm panel. You go through a step and it actually reads the serial number. The code that you saw earlier on, that's a serial number that's unique to that sensor. And before you ask the question of can you mess with that, I haven't yet tried. I'm trying to figure out if I can cause the system to transmit a signal which spoofs an RF sensor. That's to-do list. Yes, sir. Asked if the, do you mean the RF sensor or the receiver? He asked if the receiver was integrated or if it's an integral part. This manufacturer has multiple models. There's a transmitter, which is a separate module attached to the bus. There's a receiver, which is a separate model attached to the bus. There's also a transmitter-receiver keyboard combo, which is attached to the bus. So all three of the above is the answer to the question. And you can come and take a look. I've got some of the items up here. People are more than welcome after the talk to come and take a look at the items. If we have enough time, we don't have to clear the stage. Okay, he's asking if you jam the sensor, if that causes an alarm. There is a facility in the higher end panels that will detect RF interference. And the receiver apparently has some mode of detecting RF interference. I haven't yet fully identified it, but if you jam a sensor long enough, the panel will alert and say that the sensor has not checked in. So the sensor has to send a keep alive signal every so often. Otherwise, it will send an alert which does